Let's find a particular solution for the differential equation y double prime minus 3y prime minus 4y equals 3e to the 2t. We'll use the method of undetermined coefficients. We need to find a function y of t such that when we compute y double prime minus 3y prime minus 4y, we get 3e to the 2t. Since the right-hand side is an exponential function, and exponential functions reproduce themselves through differentiation, we assume a particular solution of the form y of t equals a times e to the 2t, where a is a constant to be determined. Now let's compute the first and second derivatives of our assumed solution. The first derivative y prime equals 2ae to the 2t. The second derivative y double prime equals 4ae to the 2t. Now we substitute y prime, and y double prime into the left-hand side of the differential equation. We get 4ae to the 2t minus 3 times 2ae to the 2t minus 4 times ae to the 2t. This simplifies to 4a minus 6a minus 4a all times e to the 2t, which equals negative 6ae to the 2t. We set this equal to the right-hand side. Negative 6ae to the 2t equals 3e to the 2t. Since e to the 2t is never 0, we can divide both sides by e to the 2t, giving us negative 6a equals 3. Solving for a, we get a equals negative 1/2. Therefore, our particular solution is y of t equals negative 1/2 e to the 2t. Let's verify that this solution works by substituting it back into the original equation. We have successfully found a particular solution using the method of undetermined coefficients.